Hello everyone, welcome to this session. So in this session, we will introduce a few methods to avoid overfitting, which you may be used in the future. The first way we can talk about is we call it the regularization method. So regularization method is not only applied to neural network, it can apply to any machine learning methods. So here we can see that what does it do? We can see often we minimize the error function as a loss, but here we added a weighted regularization term. We call this I regularization term. And with a weight, we call it lambda. Now we optimize this penalized function. So then when we do that, so we can see if we don't use this term, we just optimize the error function as we used to do. When the model becomes very complex, right, if we can some sort of saying that because of the complex function, it can remember each pair of data xi and yi, and this causes overfitting. So let's see this figure. I want to feed the red points, right? So consider the machine learning model generate a very complex model, such as a blue curve. So we can see that this curve clearly catches the red point, but of course this one will have a bad generalization ability. When we add this one, the regularization term, we want to penalize the complexity of the model, right? So the more complex, the larger of this item, so then the total function becomes larger, right? So by penalize the complexity of the model, it can generalize to new data samples, right? And also this weight lambda is important. So if this is too large, then this item will dominate this loss function, and then it may lead to underfitting. So if this lambda is too small, this item may not have a big impact, right? So this lambda needs to be carefully selected. And more details for regularization, you can use this hyperlink. Now let's see that how regularization method works. There are mainly two kinds of regularization method, L1 and L2. But the goal is the same. We want to penalize the complexity of the model to improve the generalization ability. So for L1, this is the formula. We call it a lasso regression. So we sum the absolute value of the model parameter coefficients. We call it beta. So we sum the absolute value of that, right? So let's see that why we use this RF can penalize the complexity of the model. So now we are minimizing this function, right? So let's consider there is so in neural network, we think the model parameters are W and B. So let's make it simple. We consider W. So we consider there is a W, and this one linked to an important feature, right? So if we minimize, we reduce this the value of that W, so this will cause problems in the error function, right? So it won't be done. But however, if there is a W linked to a less important feature, doesn't have much impact. So then, if we minimize this coefficient, this one won't have much impact. Not much influence will be added to the error. So in this way, then the coefficients for this W, right, we can make it to 0, right? So this makes the model complexity be lowered, and so as to improve the overfitting. So we can see this figure. So the red line, we can see this is a optimization counter, and we are minimized. So this is the beta with a hat. We consider this is an optimized parameter, the model parameters, and assume this is overfitted. Then by using the L1 regularization, in this case we make the beta 1 comes to 0. So by using the L1 regularization, the less important coefficients can be shrunk to 0. So the model complexity is reduced. Then the overfitting is improved. Right? So this is a L1 regularization. Another one is a L2 regularization. Due to penalize the complexity of the machine learning model, we use a different formula. We call this L2 regularization ridge regression. So instead of we sum all the model parameter for efficiency together, the absolute value of them together, here we sum the square of them, right? So in this way, we hope to draw the beta back to the origin evenly for each of the coefficients, right? The model coefficients. So we can see consider the beta is a optimized one, and by using the L2 regularization, it may come to this point, right? So this is another way to reduce the model parameter coefficients so as to make the model simpler, right? Another way is to introduce a validation set. So we can see originally we divide the whole data set to the training set and the test set. The training set is for the train to optimize the model parameters, and the test set is for evaluation of the model. Now we can generate a validation set. So this is similar to the test set. The goal is to evaluate the model while training, right? While training. So how can we do it? So we can stop the training when the validation error remains unchanged or become worse. So why this can help? So we can see the following figure. So the epoch is here, the loss is here. So this is the training data. So we consider that if we only see the training data, the loss function will always decrease, right? But we can divide this to two phases. So in phase 1, the model parameters are optimized to catch the general trend between the input and output. And this is what we want, right? And at some point, the optimization becomes to catch the minor details of the data, causing overfitting. And this is not what we want, right? However, only looking at the training set curve, we can't identify when this change happens. But however, by a validation set, we can observe it. In the first phase, the validation set will improve together with the training set, right? But at some point, because the training set will try to catch the minor details, but the validation set won't. So the error of the validation set could remain unchanged or even grow. So now this point is a time to stop. So the model parameter will stop the updates at the minimum validation loss. So this is a clever method to avoid overfitting. And in neural network training, so sometimes we use 80% at the training set, and the validation and test set, each one of them 10%, or sometimes 70% of the training data, and the validation test is 15%. And there are some other ways to divide it that are commonly used. So I list them here. So now here I introduced the third way to avoid or improve the overtraining. Okay, thank you very much. Bye-bye.